You getting my slide?
Yes, sir. Please continue.
Okay. So I welcome you all. Although I am not here, but I am delivering this lecture from Indian Institute of Remote Sensing, located in Dehradun. I hope that you may have already gone through the geospatial technology and its application for preparing various thematic maps. Here, I will not go in detail, but just introducing that when we talk about the geospatial technology, means it includes remote sensing satellites and their applications in mapping and monitoring of the resources, integrating various thematic layers which you have prepared as a GIS layers using GIS softwares, and third, that you are getting a reliable information and reliable position using GPS. So these three technology integrations is known as geospatial technology. It provides you the reliable, updated, spatial information of soil, crops, terrain, geology, and many more. If we go with the lecture, which is scheduled on soil erosion modeling and sediment yield index or yield estimation, so I am coming directly to the topic. As you are aware that the soil erosion is a serious threat to sustainability of agriculture. Our lands are getting degrading day by day because of our misuse or mismanagement or not using the proper agriculture technology or proper management. It adversely affects soil productivity and it also affects our environmental quality because removed soils get deposited in your lake, water bodies, or river, and that pollute your water bodies with the sediments. And sediments are not alone. With sediments, there is a lot of nutrients are also there. For example, nitrogen, phosphorus, potassium, organic carbon. Those nutrients also get lost from your area and get deposited in that water bodies. So it is increasing the making poor the environment quality of the water. So today we are having various models which are coupled with GIS and they are being used for estimation of erosion, runoff, and understanding the erosion process. How serious this problem is there? I just cite one reference, that is the estimation of soil erosion in India. Long back, it was estimated by Central Soil and Water Conservation Institute that if you see the average loss of soil erosion in India is 16.35 tons per hectare per year. But what rate we can permit or permissible rate? It is supposed that is 4.5 to 11.2 tons per hectare. It means that is the when the soils are shallow, as in case of Himalaya region, in case of Kashmir or in case of J&K, entire Uttarakhand in our place also, thickness of soil is less. There you can allow only 5 tons per hectare per year. But these area are getting erosion very severe even more than 50 tons per hectare per year. If you see about 29% of total eroded soils is lost permanently to the sea. So because of erosion, your soil get removed from your area and lost to the sea. And it has been estimated that 10% of the sediment or soil get deposited in reservoir, lake, or other water bodies. Well, and 61% of the total erosion what take place, it get dislocated from its original place. So you can say that 40% is removed forever and 60% get redistributed over the area. So in some fields it removed and other fields it get deposited. If we see the what is the condition of how much area in India getting affected. So land degradation in India, it has been estimated that the area is around 120.4 million hectare. 120.4 million hectare. And if you see the major land degradation types, that is in agriculture land, or what are the major cause of land degradation? First cause is water erosion. That is your 70% of our area of total degraded lands of arable lands, meaning agriculture land. 70% of agriculture land are getting water erosion. Around 12% are getting wind erosion. 16% are chemical degradation. Chemical degradation include salt affected soils or acid soils. 1.1% is affected by physical degradation, means land deformation. Like that one, you can say 104 million hectare of agricultural land is getting affected by land degradation, which is 86% of the total agricultural land. And forest land also are affected by land degradation mainly because of water erosion, around 14%. So land degradation doesn't mean that it only takes in agriculture, but it also takes place in forest land. If you see the mechanism how it takes place, you know, in the area on or a hill slope, when rains, when you see the rains drop falls on the ground, it detaches the soil particles, and the soil particles get transported through runoff and deposited in another field, and some part get away from fields to the water bodies or lake. So erosion mechanics, you can say there is a three process: detachment, transport, and deposition. Three processes are there. If you see, so in the beginning, top soil is removed, that is known as a sheet erosion. When a particle get rain are hitting your ground, that is known as splash erosion. When thin layer is removed, we call it sheet erosion. And when this runoff water get accumulated on the depressional area, then it forms the rill. So you are getting minor drainage channel. But usually in the agriculture field, it is very difficult to see those rills unless it becomes a very wide. But all the water, runoff water get accumulated of this area and then go with a high velocity and forms the gully erosion. So you can say the splash erosion, sheet erosion, rill erosion, and gully erosion. These are the stages of erosion or erosion types. And the three important parts are there: detachment, transport, and deposition. If you see how it happens, if you assume this is the soil and this is the precipitation, rains are coming, and these rains water get absorbed by the soil. That is, you are knowing it is a infiltration rate, or also because soil have the water holding capacity, so it absorb the water, but the remaining water, around 40 50%, 40% it get absorbed, but 60% of rainwater in general get removed or move through the surface. When it moves through the surface, it causes erosion. If your soil is porous, then most of the water will go. But if your soil is compact, hard, then water will not infiltrate. Most of the water will get run off. So you can say it is also depends on the water balance. And you know, some of the water get transpiration, because vegetation, you are getting vegetation transpiration, and from soil evaporation, so you are getting evapotranspiration. So this is the in nutshell how the runoff water get produced. Right side, if you see the picture of Dehradun agriculture field, where are the terraced agriculture, where farmers having terraces, and you see the runoff water from upper area, it is coming down and moving from each agriculture field, and this is the water having sediments, or it has removed the thin layer like sheet erosion, and water is moving and causing soil erosion. If you see the, if I summarize, the soil erosion process is detachment, transport, and deposition by erosive forces of rainfall. One thing is, remember that rainfall, when the rain intensity is high, and it is assumed that if rain intensity is more than 10 millimeter per hour, then only that rains cause erosion. So 10 millimeter per hour. So if we have the good meteorological data of every 15 minutes, then we can calculate the rainfall erosivity. So you can calculate the rainfall erosivity using rainfall data, and there is equations are there where you can calculate the rainfall erosivity, because rain, it is producing the runoff. Second factor is causing the soil. What kind of soil is there? Some soils are easily to erode, erodibility of soil. If soil having large amount of silt concentration is high, then it is supposed to be more erodible. So erodibility depends on what kind of texture of soil is there, what, how much organic matter present in the soils, because that governs the in water movement into the soil, or it is related with the structure of the soil. Third factor is the topography. Topography is one of the most important factor which control or which governs the soil erosion. In topography, there is a two things are there. One is the length of the slope, how long slope is there, and another is the gradient of slope, what is the steepness of the slope, and fourth factor is vegetation cover. If your soil is covered with the vegetation, then what it will do? The rains coming from the above, their energy becomes reduced by the vegetation cover, because vegetation cover will provide the protection to your soil surface, and it reduces the rainfall energy. Then what happens? the rain intensity becomes less, and therefore rainwater enters into the soil through infiltration. So vegetation cover reduce your soil erosion. And last factor is that is the conservation measures. What farmers are doing the conservation, because we need to protect our soils against the erosion. So we do the various conservation measures. For example, agronomic measures, we do contour farming, or sometimes we do that is the mixed farming, or row cropping to as a conservation measures. In mechanical, we do terracing, bunding, or sometimes trenches. We do that trenching so that water gets stored into the trenches. So by and large, you can say there are five factors which are affecting the soil erosion. So if you want to estimate the soil erosion, then you have to consider, or you have to estimate all these factors. So you see just a pictorial. This is the when rain hitting your surface, splash erosion. This is the sheet erosion in the agriculture field. In the patches, soils get removed, and that is you are getting as a sheet erosion. When in the patches it is removed, then it flow and it forms the rills. You are seeing these are the rills, but these rills are not so deep, not so wide. You can, if farmers plow the land, then it will go vanish away. Here, if these rills get wide and deeper, then we call it is gully erosion. So you can see this is the picture from Dehradun is terrace land. Their overland flow or runoff water is moving, and this runoff water having lot of sediments, soil particles, and these soil particles also having on the soil particles nutrients are absorbed. So you are not losing the nutrients, but you are not losing only the sediments, but you are losing the nutrients from the surface also. Therefore your soil's productivity or fertility declined. Here also you can see when the runoff amount, even this is the forest area, when the runoff amount goes down, then it removes the soils or landslip. And you know, this lands because of landslip, this soil or this land area is lost forever from your country. Entire area, or this, if suppose it is 1 meter wide or half meter wide and 10-meter length, so you can say 1 into 10 meter, that is 10 square meter land has been vanished from your state or from your country. So this is a very serious issue. Because of erosion, you may losing your land area also. Can we map this soil erosion from your satellite data? You have already studied the remote sensing data, false color composite, what we use. Here I will show you this picture of Shivalik Hills of Dehradun, and you can see here that is the here you in this circle you are seeing the very linear features, that is coming density of that linear feature, which we can call it is gully. Another form you can some people you can alternatively call it is drainage pattern. So drainage density is high, or you can, I will call it is gully. And here you see this is the area under the forest, but you see the forest red color on FCC appearing, it means forest. And here you see the this drainage density is not high as compared to this place. Here drainage density is less. Here dense forest and drainage density here is more, but here is less. So you can relatively you can see the drainage density, and this drainage density, and here you see this area, you are getting whitish color because of high reflectance, because this area top layer top layer has been removed, or you can say the sheet erosion. And when the top layer is removed, it means clay particle and organic matter has been removed from this area. Clay particle and organic matter. And depth of the soil is also will be lesser. So what is left there? When fine particles is removed, then sand and stones will left in the soil. Because of sand content high, your soil is getting high reflectance. So you are getting whitish stone. But here if you see, it is little more reddish stone. Or you can say that is the here erosion has not taken much place, has not taken much. So if I say this places, you can from false color composite itself, you can interpret the erosion class, qualitative erosion. If there is a here maybe splash erosion taking place, so I can say this is the E1. Here the sheet erosion is taking place. I can say it is E2, and some rills formations also taking place here. That's why here moderate erosion. If rills are there, then you can say the moderate erosion. Here you are getting the gully and network of gullies, very high frequency gullies. You can say very severe erosion, this one, and here is the moderate erosion, or severe erosion. Here is the severe erosion, here is very severe erosion, here is the moderate erosion, and here you can say the slight erosion. So I can interpret it like that one to get you more clarity using remote sensing data, false color composite. If you make the interpretation key, you can also map the erosion class without any computer analysis. You see, these are the area I am showing very severe erosion. And very severe erosion means when I say the sheet erosion, even class, it means 10 to 25 tons soil removed per hectare per year. If sheet and drill erosion both are there, which is here, I can say it is 25 to 50 tons per hectare. This is the severe erosion, gully erosion E3, 50 to 100 tons per hectare. And here is the dense gully erosion, you can say more than 100 tons. So you can see, you can, once you see the image characteristics on your FCC, then go to the field and confirm this one, that erosion is how taking place. So these features you can validate in the field, and you can collect some soil sample also to analyze that is what is the clay content or silt content present into the soils. As I told you, soils, this area you are getting high reflectance because soils having low organic matter, because the top layer has been removed by runoff. Therefore, organic matter and clay content becomes less. So these were the quality. These were the qualitative estimation. Thereafter, we will switch over toward the how to model the erosion. So erosion modeling, then we have to understand the processes of erosion. And I told you the erosion mechanics, that erosion is a three-step process. First, soil particles should detach, then transport, and then deposited another area. Then we call it erosion. So for that, there are various models are available in the literature. Then first question comes to you that why we want model. Can we not do with visual interpretation? Yes, we need to answer some questions. That's why we need models. Models is useful to estimate important quantities. Means what is the rate of erosion? How much water is getting run off? How much sediment loss is there? This important quantities you require to I want to know. Otherwise, I can say high erosion, moderate erosion, very high, but that will not serve the purpose. We need the quantitative. That's why to estimate important quantities, model help us to predict the future. In future, because of climate change, maybe rainfall may increase in future. Then what will be the erosion rate? May farmers switch to other crop or plantation crop or some forest degradation take place? Then what will be the erosion rates? That I can predict the future with future erosion rates with the models. And these quantities help us to develop a management action plan. But there are problem with the modeling. Lot of problems with modelings are there. Classical approach means when we conduct an experiment at your field, your university, then you are getting a particular field information in classical methods that are known as a classical method. When you are conducting experiment and you are calculating the erosion rates, but what is in this approach what you lose? It ignores the spatial variability. Means other place where the experiment has not conducted, how is the erosion rates? That also we want to know. So in modeling we can do that with GIS, remote sensing. Models are often difficult to build, use, and understand. You have to understand whole models, not only one parameters, all the parameters, how they are behaving. Third, there are few common general models are there where you need a customizations using computer. And the last one and very important, models response is often wrong. If you are not understand the model, you have not prepared the good thematic layers or maps, and you are using the models, then your results will come wrong in general. So under proper understanding of the various parameters and their range and their calculation is very much important. Otherwise, models will predict wrongly. Who has done this modeling? You come to that one. First model developed in the world is USLE model, Universal Soil Loss Equation. This model was developed by Wismere and Smith, these two scientists in USA conducted series of experiment. You see the plot experiment. They conducted plot experiment and the plot was 22.1 meter long, 1.83 meter wide, and has a slope of 9%. They have made the standard plot and conducted throughout the USA, mainly eastern part of the USA, and they have get the data of 10,000 plots year. So much of data they get, and then they develop the model that is universal soil loss equation. Usile was originally developed at the plot scale, agriculture field, because in USA in 1960s they were they thought they have come realize that erosion is a very serious problem in agriculture land. So that's why they started systematic experimentation, and they found that is there are five factors are there. One is the R, that is I told you rainfall energy. K, soil erodibility. LS terrain factor, P management, land management, and C crop management or crop cover. These are the five factors. If you estimate that one, you can do the erosion estimation. Universal soil loss equation is the most widely used models. It is empirically based, and Usle is can be used only for the simple plot but cannot be used for the complex situation. Later on, they the laboratory where this they developed the Usle model. This is the building of the National Soil Erosion Research Laboratory in US. They developed a very complex erosion model, that is WEP model, Water Erosion Prediction Project, and this is the model which gives the process based modeling. And when this model is known as the empirical model, where the relationship between observation and factors has been established. Factors, suppose R, K, Ls, these are the factors. And in this factors, what was the observation? What was the soil loss was there? They established the statistical linear relationship. And then they developed the model. That's why it is empirical model. But you know the empirical models have their own limitations, although it is universally used, but it has a lot of limitation also. And the best model today available is the process based models, and among them WEPP, wet water erosion production project, is the best model. But it cannot be used for the large area, it can be used for the smaller area. If you see the erosion models, we can divide into three types of models are there: empirical models based on the observation, semi empirical models, and physically based model. Physically based model are the best model. They essentially describe the mechanism of erosion. They How detachment will take place, how deposition will take place, how transport will take place, what are other factors are affecting. So all complex interaction will be are taken into account through various mathematical equations to calculate the soil erosion rates on temporal basis and on spatial basis. Temporal means physical based models, they can estimate of every hour, even every hour, every day, week, month. But empirical models are in general, they estimate annual erosion, yearly erosion, not daily. Another group of model is semi-empirical model. Semi-empirical is between the two. Some of the more explained mathematical equations, but semi-empirical models are especially lumped form. Means they are the watershed models. So I will come later on. These are the examples: empirical model, Usle model, Musle model, modified universal soil loss equation, Rusle model, revised universal soil loss equation, and you see these are the annual erosion rates. Semi-empirical models are SWOT, Apex, and you see this is the watershed model basically. Here, SWOT model today you are getting also continuous daily rainfall, daily erosion and runoff you can calculate, like Apex model also. But if you see in the basic SWOT models or Apex model uses Musle equation. Third model is the process based, physical based model, and among them, the most important is WEP model, WEPP, Watershed Erosion Prediction Project. It is event based, every event you can measure, and it is continuous. If you see the internationally, which models peoples are using maximum, Although in the world, lot of models are available, but you can say 42 or 43% of the research is being done with the Rusle model. Rusle means revised universal soil loss equation. Usle equation I have shown you. Now I will tell you about the Rusle model also. And other models you see, SWOT model 4%, answer. In these are the web model you see 2.2% researches have been done. Because these models requires a lot of information. That's why their popularity is not there much. Rusle is a simple model and give a very reliable estimate, and it is GIS compatible, remote sensing and GIS compatible. That's why Rusle is most popular in the world. Now, first I will show you the Usle universal soil loss equation model. As factors I have told you already, and if you factors you divide into three, our rainfall is hydrologic cycle factor, means rainfall. K and LS, it is related with the soil and topographic factor, and C and P related with the land management factor. But it is the plot scale model for agriculture fields for simple slope. It can be used for the agriculture area, but what about forest? This model cannot be used. It is useful for the simple slope. I told you if but slopes are complex means you have convex, concave, different slope. So Usle model cannot be used. Usle model, if you write in mathematical form, then this is the A means soil loss, EI is the rainfall energy, EI 30, E means kinetic energy of rain, I means intensity of rainfall of 30 minutes. K soil erodibility, L is the slope length, filled, filled length divided by 22.1 meter, and this is the S. You can say the steepness means sine theta is the